Did you hear that beep? Means we're starting. All right. Hi, everyone out there in YouTube world. Today is February 12th, 2021. Maybe I shouldn't say the date in case that's going to make people not think the video is relevant in 5 or 6 years. Anyway, we're looking at determining, oh, there's an A there. I can even use that A. That algebraic expression, express yourself, or also called finding the nth term. They mean the same thing. They are synonymous. Nth term could be an N we use. Algebraic expression could be an X. It's up to you. All right. So we're going to do this for linear sequences only. Linear sequences. Not sequence. Sequences. You call them flippies. Flippy shirts or whatever. We called them sequins when I was a kid. And we also use long division. All right. So let's make a linear sequence. Sequence. Let's go nice and simple. 6, 9, 12, 15, carry the 1, 18. Just kidding. That's fire enough. All right. Now, some people like to put this in a table of values. You down with TOV? Yeah, you know me. We'll call this, I'm going to use X. And we can call this Y. You can call it other things too. X is 1, first term, second term, third term, fourth term, fifth term, sixth term, or nth term. It could be N as well. Y is, well, we're just going to fill in the numbers here. 6. I hope everyone's writing this down. 9. Even you listeners at home. 12, 15, 18, 21. I went further than I needed to. Now, you may like this technique. It's probably a good habit to get into. What I'm going to do is show you an algorithm, just a thing that works well for me. What I want to do is determine the difference between every term in the sequence. Because it's linear, you should trust that it goes up by the same amount every time. Otherwise, it wouldn't be linear. Non-linear. Geometric. So it goes up by 3 every time. I know that everyone out there in YouTube land and in this class can do 9 minus 6 and find 3. Or 12 minus 9 and find 3. Or 12 minus 9 and find 3. Or 15 minus 12 and find 3. So all you do, and again, if you don't know why this works, I went pretty far in mathematics not knowing what the Pythagorean theorem really meant with the area of the different parts of the legs and the hypotenuse, and did pretty well at math. So, I don't know how a jigsaw works. I just know how to use them really well. Okay, so I'm telling you, all you have to do is take that number, whatever it is, positive 3, and put it in front of the letter X. We're almost done. It's that easy. Now, here's the trick that I've been doing recently. I'll show you the not trick and then the trick. So what you can do is you can substitute 1 into this little expression and go 3 times 1 and you'll get 3. But wait, I need to go to 6. So what do? You add 6. Or what you might find even easier, and this is the little trick I've been using, cover X, ignore it for a while, and look and see how far you need to get from here to there. I need to add 3. And then just add 3. And you're done. And Robert's your mother's brother. Or Bob's your uncle. So, that's it. You're done. Now, if you want to check your answer, it's always good to do so. Check your answer and see if it works for all of them. So let's substitute 2. into here. So I'm going to substitute 2. So I'm going to go 3 times 2. 6 plus 3, is it 9? Yes. He really is my mother's brother. Okay. Bob's your uncle's an expression. It means like, there you go. My friend says, Robert's your mother's brother. And then one time I said it in class and a guy put up his hand and said, Robert is my mother's brother. So Bob was his uncle. Okay. Here we go. Let's do another one. I'm going to make it a little more sophisticated. A little more complicated. Why you have to go and make things so complicated? Not that much complicated. 12. He did 12 again. I think he likes the number 12. I see a pattern here. That's okay. No time for patterns. So it's a linear sequence. It goes up by the same amount every time. You can figure out what it is in a second. Let's just use the little trick that we're using. Let's forget the table of values for this one and just go, okay, 12 minus 7 is 5, and write it here. Trust me, it's linear. But if you want to try another one, you could. 17 minus 12 is 5. 22 minus 17 is 5. It's going to work. Unless I make a mistake in my addition here. But if I'm trying to do a linear, if it works for one, it works for all. Okay, now I put the letter. That's it, and we're almost done. So find the difference, put it there, put it beside a cool-looking X, or a fancy N. Then cover up the X, try and determine how far you have to get from here to there. Oh, I have to add 2, and drop the mic. We're live back again with 8D Mathematics. My name's Ryan Grinnell. You can call me Mr. Actually, you have to. Okay, so let's do another one. This one's more complicated because it's going to involve subtraction. Soustraction. We're done. We're good. That's it. That's all you need to do. This pen is weak. Weaker. All right, so let's do another linear sequence. Let's go 15. Yeah, and let's go 35. Whoa, Mr. Grinnell, that is a big jump. I know. You're all capable. And I think that's high enough. All right, so what did I tell you to do? I tell you to find the difference between each term. 35 minus 15 is 20. Let me check my math. Actually, because I want to check my math this time. 55 minus 30, yep, 20, 75. Okay, good. Whew. Under pressure. So, 20. I said it was 35 minus 15 is 20. So I write that there, and then I write a cool looking X. Almost done. I covered up. But wait a second. Hold the phone. This time, the number that is first in line is smaller than this. So, rhetorical question coming up. How do you get from 20 to 15? You subtract 5. Yep, done. I don't know. Can't explain it much better than that. Not that someone else couldn't. I'm saying I can't. I'm saying I'm doing my best. Work with me, people. So, you can check it. All it needs a second to wreck it. My thoughts are collected for the funk. Expect it. Not my own. That's funk dubious. So, let's substitute 1 because this is the first term in here. 20 times 1 is 20 minus 5 is 15. Oh, yeah. Number 2, let's substitute 2. 2 times 20 is 40 minus 5 is 35. Feeling alive, 35. 3 times 20, 20 times 3, 60 minus 5, 55. Still on stride, 55. We're done. That's it. Okay? Now, here's where the real loop comes. Every one of these, rhetorical question coming, only because we're on video. Every one of these has done what? Increased. That's how you make sure someone doesn't answer your rhetorical question. It's increased. These have all been increasing. Increasing linear sequences. So, you know what that means? Let's try a decreasing linear sequence. Now, this is going to involve some negative integers. Beware. I should go back in post-production and put in that actual sound effect. That'd be cool. I should allow one of my students to do that because you're probably way better at that. That'd be really cool. Don't. Not yet. Later. Okay, so negative integers. Let's try this. Now, let's go from 30. So new linear, still linear, sequence. But you know what? I'm going to make it so there's no negative integers. Okay? No, I can't. It's too late. Too late. It's too late to apologize. 30. Let's go down. Let's go to 25. Keep it simple-ish. And do I have to start all over? 20. Right? And everyone knows the next one is 20 minus 15. 5 is 15. All right. So, what now? We do the same thing. Nothing changes. We see the difference between these two, except for we have to go, we still go, remember we did 35 minus 15? We did 12 minus 7. We still have to do that, only we go 25 minus 30, which gets us a negative integer. 25 minus 30, use your calculator if you need to. It's negative 5. 25 minus 30 is negative 5. And you put it in front of the cool looking x. And you're halfway there. Now, what did I do before? I covered the x, and I saw how far I needed to travel to get from that number to that number. I have to go from negative 5 to 30, or again, you could do 30 minus negative 5, but then you're doing that whole subtracting a negative and it's adding. I would just start at negative 5 on a number line and go up, or you can do the subtracting a negative thing, and you'll find out it's 35. 30 minus negative 5 is 30, or you have to get from negative 5, you have to add 35, right? If you're at negative 5 degrees, which it's way colder than now, and you want to get up to 30 degrees, yes, please, then you have to add 35. And you're done. You can check it if you want, but you're going to have to do that whole negative integer thing. You can use a calculator. So first term goes in there, negative 5 times 1, yeah, plus 35, that works. That's what we based it all on. Second term, substitute 2 into x. Negative 5 times 2 is negative 10, plus 35 is, 25. I was doubting myself there for a moment. Just kidding. Third term, substitute 3 in, so negative 5 times 3 is negative 15 plus 35. I'm assuming it's 20 because it's just going to work. And then we're done. Grab the pen and drop it.